Hey there guys, welcome to your Unit 2 review video covering the Unit 2 test review. These problems are going to cover the discrete problems from this review, which involve questions 1, 3, 6, 11, and 12. Now starting with question 1, the first question to ask is it a function or not? Don't forget the definition of a function tells us that for every x, there's exactly one y. Or generally, what we're looking for is that there are no repeating x's. Well, if I look at my x column, I don't see any repeating x's. Now be careful, you do see a 1 and a negative 1, but these do not count as repeating x's. Similarly, 3 and negative 3 do not count as repeating x's because one's positive, one's negative. However, you do see that you do have 2 repeating 2's and 2 repeating negative 2's. However, they are in the y column. This is really important. It is okay, you'll hear my dog in the background, it is okay to have repeating y's. It is not okay to have repeating x's. So in this case, is this a function or not? Yes, because there is no repeating x's. Once again, repeating y's are okay. Now for domain and range, when you have a table, it gives you a set amount of points. Therefore, this is the one we write as a list. Domain covers your x values, so all the numbers under the x column. So we have 1, 3, negative 1, negative 3. Don't forget that we have the rules. There are 2 general rules for discrete functions, which are do not write repeating values and write it from least to greatest. So if I wrote 1, 3, negative 1, negative 3, this would be counted incorrect. I have to write my numbers from least to greatest, so I have to rearrange it. Negative 3, negative 1, 1, 3. These numbers are now from least to greatest. Be careful, negative 3 we consider smaller than negative 1 because it's more left on the number line. You can also think of it as if you have negative $3 in your bank account versus negative $1, you have less money with negative 3. Now for range, same idea, except that range covers my y values. So it's the second column in my table. Now, if I had written 2, 2, negative 2, negative 2, that would be incorrect because it's not from least to greatest. But if I wrote negative 2, 2, 2, that would also be incorrect because it's least to greatest and no repeating values. So I only have to write the negative 2 once, and I only have to write the positive 2 once. You do not have to write them if they repeat. That's really important. So the 2 rules are from least to greatest, no repeats. Now we're going to go on to problem 3, which is another discrete function. This one is a mapping function. So it's still asking, is it a function? Well, generally we ask ourselves, do we have repeating x's? So I have a 3 mapping to a negative 1. This 3 only has one y, no repeating x's. 0 goes to 0, negative 3 goes to 0. They're sharing an output value or they're sharing a y value, but that's okay. That does not count as repeating. Negative 6 to 2, it all has 1. So yes, this is a function. Generally for mapping, what you're looking to see is that our x's have one arrow and one arrow only. So you see this has one arrow, this has one arrow, this has one arrow, this has one arrow. Therefore, they are functions. Now they do have arrows that they share, but that's okay. As long as your input values all have one arrow and there's no repeating x values. Now domain is still all my x values. So I look at this circle right here. So remember, no repeats from least to greatest. So in this case, my smallest number is going to be the negative 6. Let me give myself more space. The negative 6, negative 3, 0, 3. So once again, I just reordered it from least to greatest. Then I'm going to do my output, my y values, or my range, from least to greatest, negative 1, 0, 2. And that's my domain and range. Number 6 is similar, except this time it's a graph that has discrete domain and range. Now, remember to do, is it a function? We generally do something called the vertical line test, in which we kind of imagine drawing vertical lines through every single point. And generally what you want to do is to make sure that these vertical lines I draw throughout my graph only hits one point at a time. So this line's okay. It only hits this single point here. This line's okay. It only hits a single point there. However, notice on my y-axis, there's 2 points. That's not okay. Therefore, no, this is not a function. So generally, if you have 2 points on the same vertical line, it is not a function. It only is a function if every vertical line has one and only one point. Another way you can think of it is if I said the names of these coordinate points, this would be 0, -1, and this would be 0, -2. Therefore, you have repeating x's, which is the 0 and the x coordinate spot. So that is not a function. Now for domain and range, there's different ways to do domain and range. You can write all the individual points for these, or I know domain are all my x values. So I can say, okay, well, what x coordinates do these points touch? Well, if I look at the first one, I always know my middle is the origin, so it's always going to be 0. 0, -1, -2, -3. So this point has an x coordinate of -3. This point has an x coordinate of -2. And by going from left to right, it's automatically going to be least to greatest because I have all my negative numbers here and my positive numbers here. Now, a lot of students will often forget to check the points that are on the axes. Sometimes it's easy to miss, but don't forget to check here. Also, be careful. Your domain will not be -1 and -2. Those are your y values. Your x values on the x coordinate are 0. Which makes sense. This is 0, -1 and 0, -2. You're only writing x values for a domain. This one right here will have a 1 to be its x coordinate point, and this one will have a 3 to be its coordinate point. So my domain is -3, -2, 0 from these points, 1 and 3. Now there's 2 points at 0, but remember we do not write repeats, so you only have to write the 0 once. Now for range, range deals with my y values. So the y-axis goes horizontally. So you kind of want to figure out what values it is touching on the y-axis. Remember, the y-axis goes vertically, up and down. And so you kind of draw horizontal lines to see. So in this case, if I want to go from least to greatest, I go bottom to top. So this one, the middle is still my origin, so it's still going to be 0 for my y value. So this is -1, -2. This is y value, -2. Then I go up 1, this is y value, -1, or y level, -1. Go up 1, there's no point on the x-axis, so there's nothing at y level 0. Go up 1, there are 2 points at y level 1, but I don't write repeats, so I only have to write that 1 once. I go up 1, I do have a point at y level 2. And then I go up 1 once more, and I notice, hey, I do have a point at y level 3. So these are my domain and range. You can also check to see if these are your domains and ranges by writing out the individual points and only writing the x coordinates as your domain and only writing the y coordinates as your range. There's different ways you can do it. It's whichever works best for you. Now we're going to go to numbers 11 and 12. So that is on the second page or the back of your review. Now for number 11, mine kind of formatting is slightly off, but this is the graph we're looking at. So we have to figure out the domain and range of this set. Same idea that we did before, but it's really important to know the difference between discrete and continuous graphs. That is in your page 8 and 9 of your notes. This is a continuous graph. Continuous graph means a continued point or connected points. So notice my points are connected as a line. However, for this discrete graph, they are individual points. They're separated and they're not connected by lines. So whenever you have a discrete graph, so I'm going to make a note to myself, whoops, that this is discrete. That means I'm going to write my domain and range as a list. So my domain is going to be all x values. So I'll do the same thing I did before. Once again, you can write all individual points. So 1, 2, 3, 4, 5, you have 6 points. You can write all the x and y coordinates of these points, or kind of break it down. So domain is only x values. So I'm only looking at the x values of each of these points. Once again, whichever works best for you. So I see my first point, And to go from least to greatest, I go from left to right. So my first point has x value 1. My second point has x values. And by the way, we're looking down here. I know a lot of times you think, oh, x is horizontal. The x-axis is horizontal, so you want to see what point here it touches on the x-axis, because these are your x numbers. Your x numbers go horizontally. That's why we're always kind of drawing lines going down. So my x number on the x-axis that is associated to this point is 1. My x number here is 2. Then I have a 3, 4, 5, and 6. Notice I have no point at x7, nor do I have any points at x0. Neither do I have any points at negatives. So these are all my domain. Now for my range, I'll do the same thing, except my y values are on the y-axis. So these vertical numbers are going to be my range. So I want to see what y level is associated with each point. Now keeping in mind that the origin is always y level 0 and x level 0. Now to go from least to greatest, I go bottom to top, so my lowest point is here, and it goes to -1. Be careful, a lot of times students will ignore points that are on the axes. I do have a point on the axes. My range value is not 5. The 5 goes to the x. The y number is the origin, which is 0. So this point here has y level 0. I go up 1, I do have a point at y level 1. I go up 1, I do have at y2. Go up 1, I do have one at y level 3. I do not have one at y4, nor do I have one at y5, but I do have my final point at y is 6. So this is my domain and range. I just wrote them out here above because there's not a lot of space here, so you can write them here, but I just wrote my domain and range here. Now for number 12, this is similar idea. We have to figure out my domain and range of these. Once again, one of the biggest things about domain and range is determining if you have discrete domain and range, which is written as a list, or continuous domain and range, which is going to be written as an inequality. Anytime you're given a graph with individual points, a table, or a set of points, you are doing discrete. The way I like to think of it is if you have a certain amount of points, for example, 5 points, 3 points, 7 points, 2 points, that you can count, then it's going to be discrete. However, here, although it looks like there's only 2 points, these are all connected points. So there's really an infinitely amount of points on this line, because this line is just a conglomeration of a bunch of points right next to each other. But basically, if you're given individual points like this, it's discrete, which means our domain and range is going to be written as a list. Now my first question, is it a function? So I want to see if there's repeating x's. I have a 1, 3, 4, -1, 3. Well, notice my x value 3 repeats. So no, it's not a function. Now you might also notice that the y value 2 repeats. That's okay. Once again, we only care about repeating x's. Repeating y's are okay, but you don't want any repeating x's. So now if I'm going on to my domain and range, well, my domain are all x values. So the r the first number in my coordinate points, because I know I write coordinate points as x comma y. So I'm only looking at the x values. I'm only looking at the first numbers in each one. Now, be careful. I'm not going to write 1, 3, 4, -1, 3, because I have to write from least to greatest with no repeats. So my smallest x number is going to be that -1. My next smallest x number is going to be +1, then 3. But remember, no repeats. So although I do have 2 3s, I only will write the 3 once. Then 4. So these are my x numbers, written as least to greatest, no repeats. Range is going to be my y values, which are the second number in my coordinate points. So these are all my y coordinates. So to write my range, I'm going to once again write from least to greatest with no repeats. I have 2, 1, 5, 2, -1. The smallest one is going to be that -1. My second smallest number is a positive 1. Then my next smallest number is 2. Now, like I said before, you have two 2's. Do not write repeats, only write the 2 1s. And then my final number is 5. So this is my domain and range. So these are all the discrete problems on your review. If you have any further questions, don't forget to sign up for tutoring or ask your teacher before your Unit 2 test, which is going to be either October 18th if you're 8A or October 19th if you're B-Day. Good luck and have a nice day.